So I figured we could just do this pretty informally. I don't have like a slideshow or anything. I figured we could just walk through the script together, and I can tell you, I'm basically planning to cover very basic natural language processing, which is called NLP for short a lot of the time. And this will be about how to break down the language into sentences, and then also like large text corpi into individual words so that you can do things like sentiment analysis, frequency analysis, and emotional language coding. So it's very brief, but I hope you can adapt a lot of this to what you'll, to your own research and use it for things that you'll hope you will find it helpful in your own research. There we go. All right, so does everyone have this script open on their own computer? Yes, okay.
No, but I think it's okay because we can go back and watch it and open our script if we need to.
Yeah, absolutely. And if you don't feel comfortable using the console window, or sorry, the just like the R GUI itself, you can always click this button knit, and it'll print out a PDF file or a HTML file, and you can just follow along there. So great. So the first thing we're going to do is, if you don't have these packages installed, it would be very helpful if you could just delete the hash mark and run these lines of code so that you can install these packages.
Can I just ask you a question, Claire, kind of just taking a step back?
Yeah.
So what kind of data is this assuming you have? Is this auditory data? Is it like typed out words? Like, what are we typically working with here?
Yeah, so this is typed out words. So I'll spoil it a little bit, and I will say that the stuff we'll be working with is, I have this very small example, which is just like a model of how a text entry in a survey might look. And then down below, we'll actually be using some public domain books. We'll be using the 2 Alice in Wonderland books, and these are just examples. But I've used this for text response data from surveys. I've used it for headlines. Tons of people use this stuff for tweets. And if you had your RAs transcribe auditory data, you could do it with that as well. I don't know how to analyze auditory data raw, but once it's been put into text form, all of this should be applicable.
Okay. And so just one more question. So if you had, say, a conversation between 2 people where you transcribe the conversation, would you need to run this separately on the 2 different people, or could you somehow tell it like where person A's line is and person B's line is?
You could definitely do that. That'll be in how you set up your data frame. But if you set it up in a specific way, and I'll show you a little bit how you can do that as well. We're using 2 books for that exact reason. Let's say you had 2 groups or 2 participants. You could very easily set that up so you could have coding for the fact that they go together as a pair, coding for the fact that each individual is their own unique person. You could code each sentence down to the word. You could go down to the letter if you wanted. I don't think we have any use for that in social, but you could.
Okay, cool. Thank you.
Yeah. So what we're going to do is, first things first, we're just going to run these packages, load in what we're going to be using. The Gutenberg R package is how we're going to download those books, those Alice in Wonderland books. Tidyverse and Tidytext are going to be the main things we're using. And then we're doing a little bit of data visualization, and that'll be some ggplot stuff. So we'll just run that. Great. Did anybody have issues with that? Great. If you have issues, there's not too many of us, so just stop me and we can do some like hot fixes, see if we can figure it out. Great. Okay, so that's the intro. The only other thing I want to briefly touch on before we get into the more actual NLP stuff is pipe operators. And the reason I want to just go over this very briefly is because it's used all the time in this tutorial and in pretty much every tutorial you're going to see with natural language processing online. They almost all use this pipe operator, and this was somewhat new to me when I had started doing these analyses. So the pipe operator looks like this. It's the percentage sign, the greater than sign. I always forget which one is which. And then another percentage sign. So at its most basic, what the pipe operator means is it means do this and then this. And it's a way of linking together commands from multiple lines of code. And this is really helpful when you're reformatting large data frames because you don't have to save a new data frame every time. So if you load in all of your conversation data, you can say, I want you to center these 6 variables. I want you to filter out everyone that didn't consent. And I want you to sort by this identification number. You can do all of that in a single command, which just reduces the error. But as a very kind of overview look at what this does, you can also think of it as something that takes code that looks like this, so function of x, and turns it into something that can be written like this. So take x and then apply this function. So as a visual example, let's say we have pi. We run this. That's pi. If I wanted to round pi to the 4th digit, there are 2 ways I could do it. So the first is the base R way, which is the f of x method, which is just round pi to the 4th digit. We run that, boom. We could also, though, run that using the pipe operator, which is basically saying take pi, and then I want you to round pi to the 4th digit. And R knows that the data I'm putting in here is this pi. So we run this. Great, we get exactly the same answer. Let's say I also, though, wanted to do more than one operation. So I wanted to take round pi to the 4th degree and then take the square root. I could write it like this. This would be totally fine. It's a little hard to read. I have found that this is like slightly complicated. So we run that, boom. I can also write it like this though. And I find this to be slightly easier to read. So what this is saying is take pi, I want you to round it to the 4th, and then linking these 2 chains together, after you round to the 4th, I want you to take the square root. And if you run that, you get exactly the same thing. Does that make sense, how these operations fit together and how they link together? Awesome. And I saw that there was...
Can I ask you a question?
Yeah, please. I saw there was a comment in the chat too.
Yeah, so I think the comment in the chat is how to get the pipe operator, which is really helpful. Thanks, Ashley.
I didn't know that, Ashley. I type it out every time.
My question is actually, so I get how it works with like after the pipe operator, you put multiple operations. Does it also work the other way around where you could put like multiple numbers before the operator? So you could do like pi and then another number and then like whatever. Like if you had like a list of numbers that you wanted to do those operations on, does it work like that too or no?
No, not
Okay.
as much. So in that sense, what you would want to do is you would want to put those numbers into some sort of vector or data frame and then run the pipe on that one item. If you put more than one thing at the beginning before your first pipe, I don't think it can run, or at least I've never done that. But if you put it into a single object and then use the pipe operator, it should work fine.
Got it. Okay, thank you.
That's a good question though, yeah.
Yeah, like when I did my messy data class, like we would get like huge data sets and put them into like a tibble or put them into maybe just a data set. I don't really remember, to be honest. But then we would run the whole thing on that. So like it can be done. It will just take kind of like a long time.
Yeah, exactly. Like what in my first, when I'm usually like cleaning my data, I have one just like really ugly pipe at the beginning that deals with a lot of the subsetting and the mutating all the columns into what I want. And you can do, but it has to start with a single data frame. So you have your, DF1 and you run all of those operations on that single data frame. It's really, really helpful. I just wanted to cover this very briefly because I use it a good deal later in the tutorial. And I figured this isn't familiar to everyone and it might be helpful to go over it quickly, but I would really encourage people to like look this up online. There's so much that you can do once you learn how to use these operators. And I really do think it makes your code a lot more readable. Like I find this to be significantly more intuitive than this, because you're kind of going back and forth in this one. And this one reads more just like natural language. All right. So any other questions on pipes before we get into the natural language stuff? Cool. Okay. So let's start. I figured the first thing where it probably makes sense to start is with a very small kind of example text data set. So let's say we have responses from participants who were asked what they got up to during quarantine. We are pulling out 3 people's responses, and it looks like person 1 learned how to cook sourdough and made her roommate sick. Person 2 watched a lot of TV, and person 3 just slept. They didn't do anything else. So we will run this, and I'm going to be running with using the Command Enter button on my keyboard, but you can also run using, where's the, okay, I don't know why this one doesn't have a little green dot, but you can also, maybe yours does, but run with the Command Enter key. So we'll do that, and we now get our little vector up here, and we can also see that in our window. So the first thing we need to do with this is we need to turn it into a tibble, which is what Ashley was talking about. So we'll very quickly do that, turn that into a data frame, and it changes the format, which allows us to run the rest of our operations. And now I'm going to add ID numbers to each response. So if we look at our data frame now, it's just the text. We don't have any identifiers with who said what. So that's what this function's doing. I'm saying take this data frame, and I want you to mutate, which basically means add a new column, call that column ID, and I want it to be equal to the row numbers. And then I'm also adding this. This says I actually want it to go before the text column. This column is called text. So we'll run that, and then we'll look at it again. And we now have ID numbers for each participant. Okay. So to examine the linguistic content of their responses, we have to break up their sentences into tokens. And here we're going to say that those are going to be individual words. As I alluded to before, you could tokenize by sentence, you could tokenize by letter, but for the moment, we're going to just do individual words. So I'm calling this tidy data, and that's because this unnest tokens function comes from the tidy text library. So I'm saying take our data that we have up here, and I want you to unnest tokens. I want a new column called word. I want it made out of the column called text that was in this data frame. And I want you to break it up by words. So we'll run that. And you can already even see in our window that the length of our data frame changed pretty dramatically. And now if we look at our data now, we have each word from person ID 1's response as its own row, which is what we want. And as you can see, if we look at our data frame, this person used a comma, this person used a comma, they use an ampersand. This doesn't have that. So when you just simply unnest your tokens, it strips the punctuation. So you don't have periods, you don't know where they stopped or where they use commas, or if they used, a semicolon, I don't know, maybe they're fancy. But let's say you wanted to keep the punctuation, you could easily do that. You just include this command, which says strip punctuation equals false. So if we run this, we now see we have the commas, and that's all preserved. I didn't save this. So see how here I assigned this new thing into a new data frame? I didn't save this, so we won't be working with this punctuation inclusive data set for the rest of the tutorial. And oh yeah.
What does it do to the ampersand?
I think it just gets rid of it. So if we run our,
so you need that to be the word and. You'd want to, if you want and in there.
If you want and in there, one thing that you could do is you could run it without the punctuation, and then you could kind of do a replace function. So you could say where, like, if you find this, if you find the ampersand, I want you to replace it with the word and if it's not that, do nothing. You could run something like that. I will say later, typically, you actually don't want words like and in your data set because they tend to just overwhelm any content words. There's so many of them typically. We call those stop words, and I'll get to how you deal with those in a second. But very quickly, I also just wanted to say that you can also do things like 2-word chunks or 3-word chunks. So if you were looking for, I'm trying to think of a 2-word, if you wanted to see if people were talking about New York, you could potentially separate everything into bigrams, which is 2-word chunks, and then look for New York as words. So if you run that, we now see we have I learned how to. The only thing to note here is that, remember person 3 who only slept, they did nothing else? Because their answer was only 1 word, they no longer have any answer. The R doesn't know what to do with that. It's not going to say, oh, well, they only had 1, so I guess I'll just include 1 instead of 2. It just comes in as an NA. So if you have text data that has a good number of those, you might not want to bother with bigrams. You're going to lose a lot of your participants' responses. Does anyone have any questions about the tokenizing? Yeah.
I do. So I have like a little bit of like experience with this, but I don't really remember. Say I was wanting to do bigrams, and then like, could you do an if and thing, or is that like a nightmare? Like if you said like an if there is 1 word, don't run this on it, and then just include whatever it has.
So the answer is I'm sure you could do that. I'm
Just
not
like
sure. I think it would be a little bit complicated. And the thing with text data that I found is that you end up often with several different versions of your data sets, especially depending on what you're looking for. So you probably do have a bigram version of your data, and then you also have a single word version. And part of that's because if we have time at the end, if everyone's not like totally like their brains are boiled at the end of this, I can talk about negations. So that's things like she was not happy. Like this person's roommate, maybe instead of saying she was mad, could have said, well, she was not happy that my sourdough made her sick. You can deal with that in natural language processing, and you do that using bigrams. So that's a really helpful way. That's a thing that bigrams are really helpful for. But for the most part, you're gonna want to be coding single words. That's how most of the tools for NLP are set up to begin with. So when you're looking online, you'll see the overwhelming majority. It's like the first thing you do is tokenize into words rather than bigrams. But you probably could.
I would love to know the negations thing if you do have time for that.
Yeah. It's, again, I think we're moving pretty quickly, so I think we'll definitely have time. And it's in the script, so you'll have it anyway. You can look through it. Any other questions about this?
Thanks.
No? Awesome. Okay. So that was kind of like a toy example, just to talk about unnesting and everything like that. But let's move on to maybe what's slightly more realistic, which is these large corpus data sets. So things with a lot of different types of language, lots of sentence structures, and that are quite a bit bigger. So first thing we're going to do is we're going to create our new data frame called Alice. And to do that, we're going to download from the Gutenberg R package, both Alice in Wonderland and Through the Looking Glass. These are I liked these books when I was a kid. So we'll run this code. And again, what we're saying is get these books, and then we're going to make a second column that's going to code for which book each sentence or each chunk, I believe is actually how they're coded, belongs to. So we'll run that. Okay. Was everyone able to run that? I know that sometimes there can be problems with mirrors and stuff. Everyone was good? Awesome. Okay. So let's quickly look at our data. So it's kind of messy, right? Like we have some, illustration. This is all of the chapter counts. And it looks like our actual text starts here in line 34. I didn't do this for the sake of the tutorial, but if you had something like that where you were working with, maybe you were interested in analyzing the way that people have talked about race in term papers at NYU or something. If you knew you had a lot of heading information, you can always cut this out and just start with your actual, like, the content that you're looking for. I didn't bother for this tutorial. Cool. And obviously, as you can see, we have the book is now coded so that everybody, each one has, if we scroll all the way down, maybe about halfway, boom. So now we have through the looking glasses at the bottom. So we know which text came from which book. And now we are going to unnest the tokens again. So take all that text data and turn it into one line per word. And we are stripping punctuation here. So we'll run this. Great. Okay. So that's huge. That data set is massive. It's 56,000 rows. And if we look at it, a lot of what we're seeing here are words that probably don't have a ton of meaning. So things like in, by, the, we're seeing a lot of those types of words. So maybe for our purposes, we don't actually really want those. Maybe we just want things like, scroll down. We want to find out how Alice was feeling, and see that this is still all the chapter information. So maybe I should have filtered that out. So she's saying, you know, she felt very sleepy in the stupid weather. So maybe she was feeling kind of negatively, but there's a lot of noise there before we can figure that out. So what we're going to do is we're going to redo that prior action, and we're going to include this second command, which is called anti-join, and we're going to remove the stop words. So the stop words are the things like the, by, for, to, and that should help make our data set a lot cleaner and leave us with the more informative text elements. So we'll run that command, and it's like way smaller. It shrunk by over half. So now we're at about 17,000 rows. And if we look at this, we can now see that there's a lot more content here. So pocket, watch, burning, curiosity, those are much more like action-packed words that are actually going to get us at the sentiment or the emotion that we're looking for, we're trying to analyze. And you can see the entire list of stop words if you just run stop words. There's over 1,100 stop words that this codes for. And if there were ones that were being taken out that you thought were important, you can, I don't know how off the top of my head, but you can do like customs. You can add some back in if you wanted, or you can add more. So we could, for example, say that chapter for our purposes is a stop word because we know that that's going to appear a lot and it's not that meaningful. Does anyone have any questions about that? Awesome. Okay. So here's where we get like a lot of the piping that I was warning you about earlier. So let's say we wanted to just see which words were the most common in each book. So I'll walk you through each line of this. So what we're going to do is we're going to take Alice Tidier, which is our data set that has the stop words removed. We're going to filter so that we're only getting Alice in Wonderland, not through the looking glass. We're just going to do the first book for this one. And this is where you could potentially look at participant 1 versus participant 2. You could look at only your white participants, only your black participants, only the people who morally transgressed. This is how you can code for stuff like that. We're going to count the number of occurrences that each word has, and then we're going to pick the top 10. And this is just a way so that this basically just orders our words so that in the graph they'll be in descending order of frequency. And then this is ggplot code. So what this does is we're saying we want the word and the number of occurrences that they have. This is how we're saying we want a column graph. I picked sky blue too because I thought it looked like Alice in Wonderland. Flips the coordinates. This is theme, title, and then this makes the text bigger. So let's actually show what this looks like. Ta-da! So I hope no one is shocked that Alice is the most common word in Alice in Wonderland. But what's interesting is that the second most common word in Alice in Wonderland is time, which also kind of makes sense. There's a lot about time in those books. We also have queen, king, don't. So that's one where maybe that's a word we want to add as an extra stop word that we could say, that's actually not meaningful. Don't doesn't really help us. So we could add that and take that out. And then let's say we were like, okay, great. What about Alice Through the Looking Glass? This is basically exactly the same code. The only difference is that we're now filtering for Alice Through the Looking Glass. Amazing. Alice is still the most popular word, but now queen is second, beating out time. Yeah, Ashley.
Okay, never mind. I was like, why am I getting queen as the first? And I don't know what I did, but I must have missed something where I pulled Alice in Wonderland instead of the Looking Glass. I don't know. It's fine. I'll figure it out.
It's possible that it's something up here where maybe your 11 is being coded as Through the Looking Glass instead of Alice in Wonderland. It's also possible, so it's always possible that I have made a mistake. So it might be that the titles are just wrong and I maybe sent you guys a slightly older version. You know what else it could potentially be? Are you hitting the green arrow? Or are you running command? Oh, you're doing command. Okay. I don't know then. We can always troubleshoot later. I am curious. I want to figure out what happened, but is anyone else having that issue when they run this first line?
No, mine looks like yours, Claire.
Looks like this. Okay.
Yeah, I have one other question, which maybe I'll get to this and it's like somewhat really unrelated, but how does this deal with typos? Is there any way to like go about that?
So there is, but it's annoying. So again, what that would be is, yeah, I know. Basically, if you think that there's a very common typo that you might be finding, I can't super think of an example, but you can always do kind of a replace in the same way that you could replace an ampersand, and say like, okay, we're looking for these things. If there was, especially if you were looking for one specific word or term. So like if you were specifically interested in looking at how people talked about, it's on my mind right now. So how people talked about like riots, like you could like add something where it's like, if it's riots, roit, like, it's a common misspelling. You could put that in and say like any of these would qualify. In general with typos though, no, it's not going to catch them, which is kind of annoying. Yeah.
I have a related question. So I'm more familiar with Luke where it will look for root words. So your example of riot, what about rioting? Do you have to add that in your example you just gave of look for riot, rioting, riots, rioter? Would you need to list those all out to cache them as the same kind of category, or does it do that automatically?
So with this, with the stuff that I'm showing you exactly as it stands right now, you would in fact need to code everything. I didn't cover stemming in this, but that is something that you can do and is really helpful, honestly. The problem with stemming is that things like time can be shortened, and time's probably a bad example, but I've seen things where words will get shortened to simply like TI, and then it's like that codes for tons of stuff, right? That codes for Timon or tying,
TIM if you want timing and time, but TIM
exactly
could be in temper. Actually, if you misspelled temper to temper,
yeah.
You know what I mean? So I get what you're saying. You need to do a little bit of like figuring out before you get to this stage of how
exactly. This is like, I wanted to make sure this was like very, very applicable and that this was a good like baseline for everybody. But yeah, if you're really serious about using natural language processing for a study, you would definitely want to look into stemming and stuff like that. But this is just a good way to say, like, especially if you're just looking for trends, right? If you're looking for like, what words are people using the most in this linguistic data? It's not our main research question, but I want to know kind of what's going on so I can figure out where I'm going next. This is actually a really good method for that, because it's very like, it's a bit coarse, and then you can take this and make it like way more refined. And people have done that so much better than I have. So it's definitely worth looking online. There's a lot of great stuff. I know I mentioned him later, but Billy Brady taught me a lot of this stuff. And then also Data Camp has a really good tutorial with tons of actually data visualization. So it's less for like statistical testing, but it shows how to make these like beautiful word connection plots and word clouds and all this stuff. So that can be really helpful too. All right. And does anyone else have any other questions? No? Cool. Well, again, feel free to interrupt me. Oh, okay. So I also just wanted to illustrate why removing stop words is really helpful. So this is that data set that we didn't remove the stop words from. This is exactly the same code as above. So it'll put out a graph exactly like this. And if we run that, oh, if I run not just one parentheses, okay, if we run that, hello? Oh my goodness, okay. Interesting, hold on. Great, okay, well, that worked. If we run that, we can see that like none of this is meaningful at all, right? Like, okay, cool, the is the most common word in the book. That makes some sense. We see that the #1 result in our cleaned graph is the very bottom one in this one. So you're losing a lot of information if you don't remove your stop words. There's reasons sometimes not to, but for the most part, if you're just doing these kind of like first pass analyses, it's a really good step. And, oh yeah, and then we can actually even put these in the same graph using a command called facet wrap. I'm not gonna go over this like super in depth. I stole this directly from Billy Brady, but if you wanted code like this, here it is, and it can be helpful. It's really adaptable to whatever you're looking for. Did I see a question? Cool, all right. So now we can get through this in like 10 minutes. This part's actually the easy part. Now that you've like tokenized your data and cleaned everything, the sentiment analysis stuff is pretty easy. So let's say we now wanted to say, great, we know what the most common words are, but is one book maybe using more positive words than negative words? Perhaps Alice's first adventure is a very positive experience and her second adventure is a really negative experience. And we want to be able to see if that's true. That's maybe our hypothesis. So what we would do to do that is we would take our cleaned data set, so Alice tidier, and we would use this function called get sentiments. And oh, I'm a tiny bit ahead of myself here. In order to do these sentiment analyses, we're going to use these pre-existing lexicons. And these are dictionaries online that have kind of validated themselves to either code for negative sentiment and positive sentiment, or things like emotion. So the Bing dictionary, the Bing lexicon, codes for negative and positive sentiment mostly. So you'll get, basically it'll look through all of the words in your corpus and it'll say this one is associated with negative sentiment, kind of affect, I would say maybe is like a broad word for it. And these ones are associated with positive. And then the NRC lexicon is a little bit different. That one codes for emotion. So you have 8 emotional categories that I'm not going to be able to remember all of, but I will show you those in a second. And those will code for words that are associated with things like anger or trust or joy. And it also has a purely negative and positive component as well. And there are other dictionaries and lexicons as well. So Tessa mentioned the Luke lexicon, which I have probably the least experience with out of all of these. And then there's also one called the Affin, which codes for intensity. So a word like sniffle maybe would be like a -1 sentiment, and a word like sobbed would maybe be a -3 sentiment. So one is more intense than the other, and it codes for differences in, intensity. We'll go with that. But for now, we'll just use the Bing and the NRC. And we'll start with Bing because that's simply spits out whether the word is associated with positive or negative affect. Any questions on those?
Do you have like a general resource that, sorry, just like maybe like a cheat sheet or something that you can think of at the top of your head that kind of summarizes these different dictionaries and like what they offer?
I will find one and I will send it to Casey. And she can.
I can always just Google it. I just wasn't sure if you like had one.
No, that's what I was gonna do too. I like know the one I'm thinking of. I don't remember what website it came from, but it went over at least those three. So it went over NRC, Bing, and Affin. Luke is kind of its own thing, and a lot of times the actual like functions are slightly different to use that one. And I happened to stumble upon these three lexicons first, so these are the ones I have slightly more familiarity with. Yeah.
And you can pull in Luke through R?
I think so, but
okay.
And here's I think actually why I didn't do it. I think you might have to get a license for it.
Oh, okay.
And this was all happening when I was at home during the pandemic, and I didn't have the ability to get a license. So I use these ones, which are they're not public domain, but they're like Creative Commons, I believe. So you're able to use them as long as you credit them. And I can send citations for these also.
Cool. Thank you.
Yeah. And Ash, did you have a question?
Yeah, I was just wondering, like, do you think it's like not actually a big deal to do the like negations thing if you're doing like a general sentiment one? Like, does it probably not affect that many words?
I would say it will be really important to look at each data set on its own. So I imagine, for example, in a book like Alice in Wonderland, probably not. Like you're not going to see, it's probably not going to matter that much. The majority of words are going to be not negated. And that's because it's, a book that had an editor and stuff like that. If you were looking at 1984, you probably would need negations because those hold a lot more meaning. Or depending on the topics that people are talking about. So I could imagine that if you were looking at moral transgressors, you might want to look at negations because people may use them to soften some of their language. If they're saying like, that's not cool or that's not okay. If that's kind of a very common sentiment, you might really want to look at it. But for example, in my data with headlines, almost none are negated, which makes sense. A headline needs to be very clear. There's not going to be a ton of like, they were not happy this happened, like that. It doesn't make a ton of sense. Yeah. But it really depends. Okay. That's why it's like good to look at, and I'll show you kind of how to do that.
Okay. I think I have to look at that, but I'm just like, ugh.
It's not hard. It's actually not that hard. I'll show you. It's like 3 lines. So I was very excited when I figured that out. All right. Any other questions? Cool. Okay. So let's start with the Bing dictionary. And we're going to code for sentiment, and we're going to do it in both books. So we're taking Alice Tidier, which is our clean data set, and we are going to get the sentiments from the Bing dictionary and compare them to our corpus. And then left join is a command. it's a dplyr command and it's kind of complicated, and I'm probably going to get something wrong. I'm sure people will correct me. But basically what it does is it says where there is a match, where there is a match, create a new column that includes this data. And where there is not a match, include an NA in that new column. Someone will correct me in the comments, I'm sure, but that's roughly what it does. For the purposes of this tutorial, that's what you need to know. So we will run that and see it saying joining by word. So we're looking at the word column. So if we look at our new data frame, we can see that we now have this new column called sentiment. And apparently none of these words have negative or positive sentiments. Let's scroll until we see. Great. So pig is coded as a negative sentiment. Mad is coded as a negative sentiment. Mock is coded as a negative sentiment. And that's kind of, first we're just spot checking to see if anything showed up. And then we can also actually look using this command X tabs to make sure that in that column we have 1,400 negative words and 765 positive words. And as we can see across both books, there are like way more negative words than positive words, but the Bing lexicon in particular contains way more negative words than positive words. The English language actually contains way more negative words than positive words. So pure counts without a comparison group, you might want to be a little bit careful of. I've fallen into that trap before. And if you wanted to see that broken down by book, here are two ways you can do that. So let's say you wanted to wonder, were more negative words used in Through the Looking Glass compared to Alice in Wonderland? So we can see, if we actually read this table in, we can see that it actually looks like there were more positive words used in Through the Looking Glass. And you could run a statistical test on this, but this is like a good way to just kind of see roughly how things are shaking out between your two sources. And you could also, if you wanted to keep it a tibble, instead of making it that kind of funky table, you could do it using piping and the group by function. And this can be helpful as well, especially if you have a lot of different categories. This is probably going to be a better way to do it rather than just when it's like a 2x2. Any questions on that? Yes.
Sorry, I have one question.
No, it's great.
So we would have to like probably do like a ratio, right? Like because like maybe Alice in Wonderland is just like longer.
So that's a really, really good point. And those are also things you would have to adjust for. So the length of total words in each book. You'd also want to check, again, I do it for the NRC, so I didn't do it here, but you'd also want to check and make sure there's no weird thing, like maybe, these aren't great examples for this, but let's say Wonderland for some reason was being coded as positive. If you had something like that where that word was appearing a lot for some reason, you might have to go in and say like, oh, okay, this isn't projecting sentiment, this is just like someone's name. So like maybe in one book, a main character's name is Joy. You would have to go in and code for that so that you're not saying, wow, the book about Joy is really happy. Like that, probably isn't a super meaningful comparison.
Okay. And so like if I was like to do the ratio, then do you use the total word count or do you use the total word count removing filler words, stop words?
So what I would do is you would have to adjust for the total number of words. And I think you would want to use either like a Poisson or a negative binomial distribution to do this comparison, because this is count data. So we can talk offline about this a little bit more, but the model is a little bit complicated, but it makes sense if you look at like the distributions and stuff.
Thanks.
Yeah, I can send you code for that also. Any other questions? Okay, we're almost done. Sorry, this went a little bit longer than I originally planned. Okay, so let's say now we wanted, instead of just saying negative and positive, we actually wanted to look at fear. You were most interested in, was Alice more scared in one of these books compared to the other? So for that, we'll use the NRC lexicon, and we do it exactly the same way as we did the Bing lexicon. So take our Alice Tidier data set, we run this, and then again, we can look and see if our coding worked, and it totally did. So there were 609 anger words, for example, 768 joy words. And one quick note about the NRC is that so like, for example, the word mad, it gets coded as 5 different things because that word is associated with these 5 different emotions. And these are connections that have been found in natural language. So some of them are going to be kind of weird. I'll tell you that. They don't all have like super great face validity for what they're supposed to represent. I can show you that in the visualization in a second. So this is just an interesting thing about how these data sets change shape a little bit when you use this. So for Bing, like it didn't change the number of entries, but the NRC, it will. You'll get more rows because one single word can be coded as several things. That's just an important note. Sneaks up on you. Okay. So let's say we wanted to see the top 10 words for each emotion, excluding positive and negative words, just since we already did that. So we'll create a new data frame called top words NRC. We'll run that. And now we're going to graph those using this chunk of code that's pretty similar to what we saw above. If you have like specific questions about it, I'm happy to answer them. But that gives you a graph that looks like this. And I know this looks like a lot. And maybe we could actually do just the top 5, for example. But yeah, so these are the top 10 words in each category that are associated with that sentiment. And remember what I said about face validity? So like tree apparently represents disgust, joy. There was another one that was weird, I thought. Surprise are all tree, apparently. And that is probably just the fact that in natural language, that word is often found in context that has the sentiment of disgust or surprise or joy, which is a little weird. So again, you have to kind of take with a grain of salt how these lexicons were created and use them mindfully, I would say. Don't necessarily just say, well, I guess trees are disgusting. Like you can kind of know that these give you some information, but they're not going to tell you the entire story. And then, so that's the NRC dictionary. And again, you could filter for just one of these emotions if you wanted to. So you were only interested in fear, you could easily do that. And then last but not least, this is the code for negations, as I mentioned, kind of teased earlier. So again, negations don't account for things like Alice was not afraid, which might have a different sentiment than what it's going to get coded as. So in order to deal with negations, we break our corpus down into bigrams. So we have Alice bigram now. We then make 2 columns that contain word 1 and word 2, like that. So now we have bigrams separated down here, and this is the structure. So we have 2 columns, word 1 and word 2. And we just filter to select and pull wherever the word 1 is not. That's it. It's like pretty intuitive and kind of simple, actually. So you look at this and you can see that the majority of times that not is used, oh, you don't want to delete stop words from this, because if you do, you'll mess up your stuff. So this is like more of a preliminary, like a sanity check type of thing that you want to do before you get too deep in. And this is sorted by number of occurrences in the data set. So the most common word that followed not was a. So probably something like not a cake. I don't know. I suddenly could not think of a single word in the English language. And what you want to look for here is, are there occurrences where a sentiment word is really often preceded by a negation? So for example, not help. That might be something worth looking at because it seems to appear kind of early in our negations, in the negations we pulled out. By the same token, it looks like this occurs 5 times in our entire data set between 2 different books. So it's not happening a ton. What you can do though is you could then filter out that those helps, whatever, and just remove them from your data set completely. And then that would get rid of your negations. And you can also make like a whole list. So if you weren't just interested in not, you were interested in, she was never scared or she was without fear. You can turn those into their own little dictionary and then use code that looks something like this to filter out any times that negations with any of these words occurs. So we have more rows here. Obviously, there's more words that are included. And you can look through all of those. So it looks like no use is actually one of the most common negations in both books. So that might be something also that you want to look into. So, whew, that was a lot. I wanted to cover some of the most important things to think about when you do these types of analyses. And I also wanted to make sure that you had a good kind of bones of code that you can then build off of that cover the different things you might want to consider. So does anyone have any questions about any of the parts that I covered? Oh, thanks, guys.
This is awesome. I think, sorry, I froze in a really awkward position. I think we have a lot of uses for it, and I think it would be great. So these different lexicons, is there like a huge battery of them somewhere? I know Karina asked about sort of finding specific ones, but I'm just kind of like, I think what your thought is on the different ones. Are some kind of more or have been vetted better than others? Like, what's your perspective on that?
Yeah, so Ashley asked about this too. So these are the ones that are included in like that get sentiment function. And I believe that in that I would look up that function, the get sentiment, and then see what it works with. Because I actually do think that there's a 4th lexicon that's included in that function that I now am just like completely blanking on what it's called. But that's where I would look it up. All of those that I use, so the NRC and the Bing, have like, they have been validated and they have been published. So they're in, I believe they're both in like some sort of methods journal. But there's also dictionaries, and this is a little more complicated. You do have to, full disclosure, like comparing your own dictionary. So I've been trying to use Billy's Moral Foundations dictionary. Mm-hmm. Comparing that to these, I wrote my own function for that. I know it is clunky. I know that there must be a better way to do it, and I haven't figured it out yet. I'm still working on it. But I guarantee you there are ways to like read in your own dictionaries or lexicons and compare them to your data sets. And you should be able to do it really fast. The function that I wrote, which I'm actually happy to share with everybody, it just takes a little bit. Depending on the size of the data set, it can take about up to a minute, which is objectively not that long, but it frustrates me because I know there's a cleaner way to do it. I just haven't figured it out. But it gets the job done, right? And like a lot of using R is just like getting the job done, even if it takes a little bit of extra time. So, but yes, there's a lot about natural language processing on things like GitHub, DataCamp, Stack Exchange, and then also just the RCRAN project has a lot. And tidy text mining is another website that has a lot. So I'm happy to compile a list of some of the more useful resources and send it to Casey, and she can forward it out to the rest of the lab.
Awesome.
Because yeah, I learned all of this, like I had 1 2-hour meeting with Billy, and everything else I like learned on GitHub. So you can definitely do it. It's totally doable.
So you're mostly using this for Twitter data?
I'm actually mostly using this for originally I learned it to analyze the Upworthy data set. So that was the headline sentiment analysis. But now I'm using it we have a lot of like backlogged text data in our lab that no one ever looks at. And a lot of times, I don't know if this is true in your lab, but we use sometimes text data as inductions. So things like trying to induce a moral framing. And we assume that those things work, but we don't really look at what people actually write while they're being induced. So this can be really helpful for stuff like that, figure out which words people are using the most often. I'm analyzing right now some data about why people voted in the 2020 election, looking at stuff like this. So it's helpful for a lot of different stuff.
Very cool.
And tweets also. People use it for tweets all the time.
I have a question, Tessa, for you. Just thinking more about these details. If, you know, for example, we like to look at like talk time and then amount of words that people like will say. Do you think that I should, like, for example, in the thing I'm going to be looking at right now with like intergroup discussions, should I remove stop words, because that would remove things like and filler words if I wanted to see like if people just talked more and said more in like one condition versus the other? Or should I like leave that in? I don't know.
Yeah, that's a good question. And I think I've been thinking a little bit about sort of what happens once you transcribe and what you should be listening to like raw auditory data for versus like content analyzing like this. And I actually think there's sort of uses of both, but they answer different theoretical questions. So I probably wouldn't use this as a measure of talk time by sort of equating words said with talk time, partly because some people just talk more slowly than other people. And when you're in a room with someone, just kind of thinking theoretically about this, like imagine you're having an interaction with someone, if they're just like filling up more time by talking, even if they're slower, they're still taking up more of that 60-minute meeting you have or whatever. I probably wouldn't equate someone who talked really fast but got it said in 30 seconds with someone who said half as many words but had lots of dramatic pauses or ums or ahs, because they're still taking up space. They're still like, you know, soaking up oxygen in the room. So I think I wouldn't use this for talk time. I wouldn't get rid of those negating words or the ums and the ahs. I think theoretically those are interesting for us because they're often indications of uncertainty, anxiety, or discomfort, or, you know, whatever. Like those are actually meaningful words for us, but they do add a lot of noise to this sort of sentiment of, you know, positivity versus negativity. So I think you probably want to think deeply about sort of what you would want to listen to like recordings of and have people make more gestalt readings of things versus using this to get more content of like the types of things people are actually saying. That makes sense.
Okay.
I mean, Wanda, you might have some insight onto this too, because I know you've for tutor both coded auditory data as well as transcripts, and you might have a sense of sort of when you'd want to use this versus listening to the data.
Yeah, I mean, my answer was going to be very similar in that I think it really matters what you're like interested in. Like for tutor, for instance, there was a time when we were really interested in like things like hesitation or uncertainty, where like excluding things like and like you know any sort of like sounds like that, or you know, things like what I'm doing right now, like hesitating and so on, is important if you're trying to figure out, you know, how confident someone is and things like that. If you're just interested in, you know, the net amount of information that someone communicated, then that might be something that maybe weren't like just looking at the words and taking out the stop words is more helpful for. So yeah, like Tessa said, I think it depends. And when in doubt, you can always do both, or like try to separate those and put that in a different category as like signs of hesitation or uncertainty and so on, versus like more directly communicating information, I think.
Yeah, that makes sense. And that was actually, I'll have to follow up with you about this for sure now, Claire, with like doing the ratios, because I was thinking, oh yeah, maybe I can look at filler words and the ratio of the filler words to the amount of words that they said, and see if that sort of can be used as an indicator of like anxiety, yeah, or something. Yeah, I mean, there's a lot to do, and I'm sure that we could also just play around with it and see what's actually like.
I am.
Are you presenting still?
Oh, hold on. Where's my, I don't know where my mute button is. Yes, Ashley, we should definitely talk about that offline, because ratios can be tricky, especially if you're trying to ratio count data. I know for a fact that that can be kind of messy. And so I would want to see the structure of your data and see what type of model would actually be best, because it sounds like it might be something like what I used for Upworthy, which is either, which is a model rather than like a chi-square or something like that.
Claire, I know you already kind of talked about this. Did I like misunderstand this, that either you or Billy actually created your own dictionary, or like?
So Billy pointed me to a dictionary called the Moral Foundations Dictionary. And now that you've asked this, I'm actually not convinced it's Billy's dictionary. I think it might be someone else's. So I don't want to not give credit where it's due. But it is called Moral Foundations 2.0 dictionary. And I have been using that for a few different things, but you could also create your own. So if there were specific words you were most interested in looking at, you're definitely allowed to do that. I think just like all psych and science, it would be helpful and far more meaningful, I think, if you were to pre-register something like that. So if you were to say, before you're analyzing, if you're planning to publish, right, if you're planning to make some sort of claim, not just exploring your data and figuring out maybe what questions to ask in your next survey, something like that. If you had a set of words that you thought would be really meaningful, pre-registering those and saying, this one specific group who got this induction, we expect would use these words more often compared to this group of people who didn't get this induction, or something like that. I think that can be a really powerful way to use these tools outside of just kind of exploring and figuring out what people are looking at. And if you do want to do more something like that, I would use one of these more validated dictionaries, something like Bing, especially for sentiment, just because it's a little bit cleaner and it feels less like you're cherry picking, at least, if you do something like that. But there are dictionaries online. I know also, I'm gonna forget every single person who's on this, but people in our lab just created also a polarization dictionary, for example. So words that were associated with more polarizing language on Twitter. And again, some of those lack the face validity that you might expect. So a word like tool maybe would be in that, where you would be like, what? Like, that doesn't have anything to do with politics, but it might be associated with tweets that were more polarized in general, or something like that. So those are, I think, as long as you have a good theoretical reason for using a specific dictionary, you should use it, because there's a ton online.
Do you have any, like, a sense of like how, I'm guessing it's not like an easy job to build your own dictionary, but like, let's say I wanted to like go ahead and create my own like negotiation dictionary or something. Is it like really complicated algorithms, or is it more just like, here are words, I want these to be categorized as this?
I think it really depends. I think if you're trying to do a broad appeal, large dictionary that's going to capture an entire emotion or a concept or something like that, then yeah, you would need more of this kind of, that would involve word embeddings, that would involve probably some level of machine learning, and I have like no idea how to do that stuff. But if you were just looking at this group of people this group of people in experiment 1 were the good negotiators. They had the most fruitful outcomes. And these people in experiment 1 were the least fruitful. They had bad negotiations, bad outcomes. You could run, and I didn't talk about it here because it is a little bit complicated, you could run something called a TF-IDF analysis on those two corpi and see which words were uniquely used by the good negotiators versus the bad negotiators. That's like the very simple way of describing what that does. Yeah. And then potentially you could pre-register that and then use those to code in study 2. Something like that, I think would be very theoretically sound. As long as you're not double dipping, I think you would be okay. I would say reach out to, I believe, oh my God. Reach out to Billy. He would know. He's like more in this world. And I completely forget. The polarization one, if you look at the authors on that, Philip might be an author on that. And you could reach out to him as well. Or Jay. I mean, Jay would also definitely know this. Yeah. He was on that paper too.
Cool. What was that called?
Polarization dictionary. I can include it in my little list to send to Casey as well.
Sorry, the you said like you could use like the TF something.
Oh, it's here, I'll put it in the chat. It's called a TF-IDF analysis, and you guessed it, Billy has a really helpful tutorial on his GitHub for this type of analysis. And I believe it stands for term frequency inverse document frequency. And it's basically a way of saying these words, it codes in 2 different like documents. So you have the good negotiator document and the bad negotiator document. It codes which words were not just most used in those, because maybe the most used word in both of those was deal or something. That's not that meaningful, but maybe the good negotiators used the word fair way more than the bad negotiators. And maybe the bad negotiators use the word swindled way more. That's like a very opaque example. What that would do is it would say, this was way more often used and uniquely used by this group compared to this other group who more uniquely use this word. That's like, again, the very simplified version of what that does. And they can be helpful. They also can be a little messy, having done them before, but depending on what you were using it for, it could be a good place to start at least. See what words were most important to which groups.
Yeah, that seems really helpful. I have one question that's kind of related to what Juana was talking about. So if, for example, I wanted to go through my data and see if people talked about like a very small select, I don't know, group of words. Like, let's say people, like I was curious if people brought up Twitter, tweet, dogfighting, like things that are related to the manipulation, just to kind of like comb through and see if that came up in the conversations. Is that something I would need? I wouldn't need to create a dictionary for that, right? That's something I could probably specify in some of the functions that you provided, right?
Yeah, I think what you would want to do, another function that can be really helpful, especially if you have a really small number of words that you're looking for, would be, it's the grepl function. And again, let me write that down in the chat. Grepl, no, don't correct me. Or, yeah. I will send, it's the function I use in that like bigger function that I like kind of created. And I will send that so you can look at that and see. But that's a good way to match words. Amazing. Especially in a small dictionary, it shouldn't even take that long. Should take only a couple seconds.
Okay, cool. Awesome. Also, just want to say you know so much about this, and this was so incredibly helpful.
Oh, good. Okay, I'm glad. I'm really, really glad. It's been like the world I've been living in for like, what, 8 months now. So it's glad to get to share it. It's really cool. It's like a cool tool. And I think in social especially, it's really great to see how people talk about these things instead of just giving prescribed, like the prescribed answers are helpful. And then also seeing how people are talking and thinking about these things unprompted can be really helpful too. And thanks for inviting me. Also, this was so fun.
This is awesome. I have one more question, which is just about contractions. So does it know that do not and don't are the same word, or do you have to tell it that?
I think you have to tell it that.
Okay.
I believe that, again, if you use either stemming or, and I do think that Luke can do that. I think Luke knows when things are contractions, but these don't. The only thing is something like don't isn't going to get coded as sentiment, it's not going to be coded as a specific sentiment anyway. But you could look at it using the negations, for example. So like you could include a word like don't here, like don't help that person, maybe would be something you'd be interested in looking at. You could include it as something here, but no, I don't think it can uncontract as far as I know.
Okay, then one last little, these are just like nitpicky, but going back to your Joy example of someone named Joy, it looks like this isn't sensitive to capitalization. Is that true?
Yeah, no, it's not.
Okay.
It's not.
So if I was like ignore Joy when it starts with a capital J and then deal with the sentences that start with Joy in a different way, that wouldn't work to deal with this like naming someone a sentiment word or like a proper noun.
I actually think I maybe lied to you. I'm fairly certain that this unnest tokens would have something where it says like keep capitalizations. If you look up this function, so in its base, it will strip capitalization and punctuation. It'll do stuff like that. And I bet there's actually probably something you could do with contractions too. But I think it keeps contractions because like dawn is a different word than don't. Yeah. And it wouldn't know how to like take that out and then smush it together, at least in its base form. There might be a way to do it if you look up this function on like CRAN or something like rcran. But I do believe there's a way, it would be some extra command here where you could say keep capitalization, and then perhaps you could just filter out the capital Joy instead of.
Got it. So any proper nouns you deal with on the back end, basically.
Yeah, that's what I would do because, yeah, that's what I would do.
Okay. Do you recommend just kind of messing around with this, seeing what the data looks like that it outputs, and then being like, okay, clearly it thinks this thing, we got to deal with this again by writing a command?
Yeah.
To like, okay.
It's like one of those things, like so many things, that is both very smart and very stupid all at the same time. So you have to kind of, it is a super powerful tool that you then have to like wrestle into what exactly you want it to do, if that makes sense.
Yeah, kind of like any other AI, right?
Like any other AI, exactly. So I think, again, if you're looking to use this to test a hypothesis, it would be really, really, really smart to get a sample, design your analyses using that sample, and then pre-register on a test set, just because I think that that's going to make your claim a lot stronger when you don't have the researcher degrees of freedom to say, oh, well, you know, tree is a weird word, and if I delete that one, then my results are significant, you know, like,
yeah.
You kind of have to take it at face value and say, with all these constraints and weirdness, this finding is robust to these different things. And it really helps
for specifically for using these dictionaries and these lexicons, right? So it's different if you're just like counting words or.
Oh yeah. If you just wanted to say how many people mentioned, how many people mentioned their own race or something, I think then, you know, that's a much clearer question. And then you're really just using the functions here. I think if you're saying like making a claim about sentiment, you have to be really specific about what you are proving and like what the constraints are and where you expect to see this really, really specifically.
Okay, cool.
Actually, I have like one more follow-up from the like contraction thing. Say like I run the bigrams with looking for negation words and I see like not very comes up like a lot. Can I just put in not very to the list of a negation word? And even though it's 2 words, it would just kind of like still let that be used?
So no, because it's going to look, I mean, I think you could do that and it wouldn't break the program, but nothing would pop up because what this code is doing, this negation code, is it's saying in that first column only does this word and this exact word in this exact structure show up. So if you had like not very, it would be like, oh, well, that never appears because there's only ever one word in column 1. So it just wouldn't ever get picked up. I think if you really, really wanted to do that, you would have to do, if there was some reason to do that, you could separate them into trigrams. Who knows if that's the right word? I'm just making that up. But you could separate into 3-word chunks and test. You would have to then separate into, like here, you would have to modify this code so that you had your separation as a space, you had word 1 and word 2 in one column. You know, it would be a little bit more complicated, but you could do it. And then you could search for not very, and it would be again in that very specific form. You could also do that if you were looking for something like New York, or if you wanted to look for something like Black Lives Matter, you could do that using those 3 words. So it's all possible. It's just modifying code, and that can take a long time just because, you know, it's a lot of trial and error.
Thanks.
Any other questions?
Well, thank you again for doing this for us. This is amazing. And everyone has the code. We'll post this if that's okay with you.
Please do, yeah.
Lots of people will find this super useful. Anything else, anyone, before we sign off?
And Claire, you can send me whatever materials you'd want to distribute to everyone.
Yeah, perfect. I'll I might actually put it in a Google Doc rather than an email and just send you the link so that it's all there.
That'll
If
work.
other people want it later, they can look at it too.
Cool. Well, thanks again, Claire. And
yeah, thanks for inviting
I will
me.
see everyone in not next Friday, but the following Friday.
That's right. Thanks so much, everyone.
Thanks so much, Claire.